We've got Daryl Osborne with us. Daryl, tell me a little bit about what you're going to be doing today.
Yeah, so it's Amazon Elastic File Systems. We're going to show how you can parallelize your data access method to get better throughput and IOPS to your file system.
Okay, so basically making things faster and easier.
Making things faster, yeah, making things faster.
Okay, faster and easier, a live demo. So Amazon EFS is what it's called.
Yes.
Okay, what else can you tell me about it?
Yeah, it's going to be a live demo. We're also going to show a new tool we released last week called EFS File Sync. It's a great way to migrate data from, say, an on-premises NAS environment over to AWS.
All right. Welcome, welcome. Come on in, everybody. We've got the Kumo Theater, a live demo starting here in just about 2 minutes. You're welcome to bring your snacks, come in, take a load off, and listen to about a 15-minute talk they're going to be doing this afternoon. So come on in and join us.
Yeah, that's fine.
Yeah,
that's good.
Unless you have any other ideas, we'll do it.
Dance as well? No.
Some kind of dancing? I'll sing.
I think we're good.
Okay.
All right, everybody, please welcome to the stage doing a live demo. If you'd like to join us, come on into the Kumo Theater. Welcome to the stage, Daryl Osborne. Yay!
Yay! Thank you. Thank you so much. So what I want to do is really spend the next 15 minutes to talk to you about Amazon EFS, or Amazon Elastic File System. It is a simple, scalable, elastic file system in the cloud. And when we designed EFS, we built it on these core concepts of high availability and high durability. So really today, what we want to do is really look at a demo of how you can quickly and easily migrate lots of data into Amazon EFS. So I built a tutorial that I put online in our GitHub repo, so you can actually walk through these steps yourself on your own time. But I'll walk through these with you today. So the first thing we want to do is say, OK, we want to write 2 gigabytes of data to an EFS file system. Right now, I'm SSH'd into my EC2 instance. It's a C4 2XL. I'm going to write using DD, and it's going to be 2 gigabytes of data, and I'm going to be using a block size of 1 meg. But the key here is I'm actually going to be doing a sync at the end of the 2 gig file. So after 2 gigs is written, I'm going to go ahead and issue a sync to make sure that that data and metadata is synced to the file system. So we'll go ahead and kick this off. And we'll see how long does it take to write 2 gigabytes of data to an EFS file system using DD. So it takes us about 10 seconds. 10 seconds to write 2 gigs of data to EFS with a 1 meg block size and a sync at the end of the file. And that sync actually syncs both the data and metadata. So the next thing we want to do is we want to change it where instead of doing a sync at the end of the 2 gigs, we're going to sync after each block. So after each 1 meg write, we're going to make sure that that 1 meg is persisted to disk. And we're going to see how does that affect EFS performance. Actually, let me go ahead and stop that really quick. I grabbed the wrong command. We'll try this one. So this is writing to my EFS file system, 1 meg block size, 2 gigabytes of data. But after each 1 meg block, I'm going to be doing a sync. So as you can see, this is much slower than the previous one. Why? It's because every disk operation I'm doing, basically writing that 1 meg file to EFS, it's making sure that that file is persistently stored on EFS. Once it gets a write success back, then it'll go ahead and do the next one. So it's a very metadata intensive operation and doing a lot of back and forths between this EC2 instance and Amazon EFS. So we'll just wait a couple of minutes. It should finish in around, I'm going to guess, 80 seconds. So it's a big difference between the first test that we did, where it took us, what was it, about 10.6 seconds to write 2 gigabytes of data. So depending on how your application accesses EFS, you could get a very fast performance, or you could get this performance here, depending on how many file operations you're actually going to be doing. So a minute and 20 seconds, around 80 seconds, or yeah, a minute 20 seconds, 80 seconds. Now, let's go ahead and change it up. This time, what we're going to be doing, instead of a 1 meg block size, we're going to increase that. We're going to do a 16 meg block size. So that means that we're only going to be doing 128 operations to that disk because the block size is larger. And that means those operations are going to be really done a little faster because there's not that many of them, really. We're also doing a sync at the end of each block. And that sync is also going to write data and metadata. So as you can see, the throughput went from approximately 25 megabytes a second all the way up to close to 96 megabytes a second. The only thing we changed was the block size. The larger the block size, the more throughput you're going to be able to do because the latency when writing to a file system is amortized over a larger amount of data. So we're able to achieve higher levels of throughput. Amazon EFS is has a distributed data storage design. So the more threads and EC2 instances accessing a file system, the more throughput and IOPS you're going to be able to achieve. So let's go ahead and modify this slightly. And we're going to be using new parallel to basically split that 2 gigabyte write into 4 threads. Each thread is going to be writing 512 megabytes of data. And we've changed the block size back to 1 megabyte. And we're still doing a sync at the end of each block, the end of each write. So remember, this took 80 seconds last time we did it. But now we're actually using 4 threads. And we'll see how long it actually takes us to write 2 gigabytes of data. So New Parallel is an open source tool that is a great way to parallelize a typical serial operations. And with EFS, it can really improve the performance and throughput. So we can see that writing 2 gigs of data now only takes 20 seconds. Well, let's continue to do that. And instead of doing 4 threads, let's see if we write using 16 threads, what that's going to look like. Each thread is going to be writing 128 megabytes of data. And now we can do it in 8 seconds. So this is actually faster than when we wrote a single file and doing a sync at the end. So this actually achieves the maximum throughput you can achieve to an EFS file system from an EC2 instance, 250 megabytes a second. So really the take home here is parallelize your application. Make sure that you're using multiple threads when writing or accessing an Amazon EFS file system. As we can see, last week we actually introduced a new tool called EFS File Sync. It's a very simple method to migrate data over to Amazon EFS. It's all done through the console, and it's simple, it's secure, and there's really a number of use cases you can use. One, you can use it for migrating data from an on-premises environment over to EFS, or you can use it from one EFS file system to another EFS file system, or maybe between one region and another region. So I've got a quick video here that will show really how quick and easy and simple it is. First, we want to go ahead and create and install an agent at the source. We have the option of installing it on-prem using ESX, so you can download an ESXi image, install that in your environment and use that. Or you could launch the agent within EC2 and migrate from an environment within the cloud to Amazon EFS. So in this demo, I've already set up my agent. It's running on EC2. I'm going to be migrating data from an EFS file system in Ohio to an EFS file system in Northern Virginia. So you really identify the source target. Here is the DNS name for my file system in Ohio. I go ahead and enter in the path of my source data, and I select the agent that I created. Next, we want to identify the destination. We select an EFS file system in Northern Virginia, the path of where this data is going to be migrated to, and the security group that will get access to that file system. Click on Next. Give this sync set a name. So we want to go ahead and give it a useful name. So in this case, we're going to call it Ohio to Northern Virginia. And we'll create the sync set. It takes a couple of minutes for the sync set to get created. And then we'll actually get starting to migrate that data. I've sped up this video. It should take a couple of minutes to actually create the sync set. Once it's done, we can select the task, the sync set, and actually start it. Now that it's available, we'll select this task, go to the Actions menu, select Start, and that's it. That's really how simple it is to now migrate data from one EFS file system to another EFS file system, or an on-prem NAS environment, NFS environment, over to Amazon EFS. We'll go ahead and speed this up, and I'll stop it after about 1 or 2%, just in respect of time. But during the process, you will actually see it progressing in real time. The percentage will count up to 100. Depending on the options you select, you could also have a consistency or verification check done at the end to make sure that your source files and your destination files are actually in sync. Once that's done, you'll get a successful operation, and now your data is in sync. If you want to run this again, you can. It's going to only do the changes that have made from the source to the destination. So this is available today in our US regions and Northern or Ireland region. It will be rolled out to the other 2 EFS regions later on this year. So with that said, do we take questions? Can we?
Yes, you can. And I can actually bring you the microphone if anybody has a question.
Excellent.
Anyone?
That parallel tool that you mentioned, does that work for like an EBS volume as well?
It does.
It does?
It does, yeah. So you can use New Parallel to migrate data from EBS over to EFS, EBS to EBS. It's really, it's not specific for AWS. It is a general purpose, really shell tool to parallelize different applications.
Okay, so, and that's an open source tool you're saying?
It is. Okay. Yeah, just Google New Parallel, GNU Parallel,
okay,
and you can have access to it. If you run Amazon Linux, we added that to our repo. So by doing a simple yum install, parallel, you'll install the new Parallel tool to your EC2 instance.
Okay, thank you.
You're welcome.
The EFS supports the encryption on transit.
The question is, does EFS support encryption at transit? It does not. So right now, we support encryption of data at rest. So when you create a new file system, you identify if you want the file system to be encrypted. We use AWS KMS as the mechanism to manage those keys. You can select your own CMK, customer master key, to encrypt that file system, and then your file system is going to be encrypted at rest. It is totally transparent to the end user or to the application because the data is transparently decrypted when it's read and encrypted when it's written. but not in transit. We don't support encryption in transit.
Anybody else?
Thanks. Yeah. Hello. Is there a CLI interface to this?
Is there a CLI for the EFS file sync? Not today. Today, the only way to run a sync task is to go through the management console.
All right, any other questions? I think we're good.
Great. Thank you.
Thank you, Daryl.